Hey YouTube, what's going on? I'm Greg. Welcome back to my machine shop. Today we're going to continue our work on our Wallaby 30cc engine with our focus being on the distributor. The Wallaby is a twin engine, so we have two spark plugs, but only one ignition system. We've got a magnet on the flywheel that triggers the ignition system near top dead center, and our distributor acts as a single pole double throw switch, and it switching between one spark plug and the other spark plug. So as the engine nears top dead center, we fire one spark plug. Next time around, we fire the other spark plug. And it is this distributor that acts as the rotary switch, switching the ignition system between one spark plug and the other. Now, what's unique in the build of the distributor is that we're going to use some 3D printed parts. This is the body of the distributor here, and it's printed on my 3D printer using PETG. You can also use ABS, which are higher temperature plastics. I would not recommend PLA. Okay, so the first thing that you might say is, but hey, Greg, I don't have a 3D printer. What am I going to do? So there's a few options for you that don't have a 3D printer, don't know anybody that have a 3D printer, or don't have any access whatsoever to a 3D printer. There are services available online that you can send your STL files to, define the parameters, and they will print the parts for you. And since they're so smart, this is the largest part. It would be quite inexpensive. But if you say to me, hey, I don't want to buy parts, I want to try to make them. Well, this can be made out of an acrylic or a non-conductive material. If you really want to go down that path, I've included the drawings for these parts, but the drawings I've included really are intended to essentially clean up and do the post-processing on a 3D printed part. You know, clearing out the holes and making sure they're the right diameter. If you really want to make one yourself, give me a yell, and I can provide a more detailed print. Or you can, if you have a CAD program, you can look at the STL files and machine one from them, one of those. In any case, we'll take care of you. Just get in contact with me. All right, well, let's jump right into it. We've got three 3D printed parts we need to make, and then we've got a few little brass components that make up the switching mechanism. All right, this will be fun. This will be different. So here's our Wallaby engine with the distributor mounted on the front of the timing plate. This is the little rotor that spins. It is connected to the camshaft with a pin in the camshaft gear. Let's take this off of here and look at the individual parts. So here's our assembly drawing for the Wallaby distributor. There's three plastic parts that we're going to print on the 3D printer: the cover, the body, and the rotor. So we have three different brass components. We have an outer contact that is attached to the second brass part, a simple terminal that attaches to the spark plug wire, and the center contact that spins because it's attached to the rotor. We'll look at those drawings in turn when we fabricate each of those parts. But other than the three plastic parts, the three types of brass parts, and some hardware to hold it all together, that constitutes our distributor. So this is the bed of my 3D printer. I printed them in this orientation. I'm not going to go into the intricacies of 3D printing. I'm assuming if you have a 3D printer that you're already familiar with the ins and outs of your machine. I did print mine with a 0.5 millimeter nozzle, 0.3 millimeter layer height, 25% infill, and 3 perimeters. I believe those are pretty standard base settings. Again, I used PETG or ABS as it's a higher temperature plastic than PLA would be. Again, if you don't have a 3D printer, there are just search for 3D printing services on the internet. You can send them the STL files and they will make these relatively inexpensively since they're so small and such a small amount of plastic is actually used. So here's our print for our distributor terminal. We have to drill and tap a hole for a 440 screw. We have to turn it down to 0.85 inches, and then we have to drill a small hole in the end that we can use to solder our spark plug wire to. Let's drill and tap the holes first. I start with a 5mm piece of brass I had in my scrap drawer. I spot drill, and tap the hole for the 440 screw. I'm going to make all three of them in one go, so I drill and tap all the holes for the three terminals at once. Then it's to the lathe. I turn down the outside diameter, then drill the hole for the terminal wire and part each terminal off. Easy peasy, right? Okay, there's our three terminals. So now let's turn our attention to something a little bit more challenging. This is our center contact for our distributor. It's made out of 16th inch brass. We're going to drill 3 holes. Then we're going to mount it in the lathe and cut it into a disc centered on the center point of these 3 holes, and then bring it back to the mill and cut off this face here. This is a scrap piece of brass I found in the bin. I think I can cut this right out of this little piece here. That should work. Let's load that into the mill, drill our 3 holes. I've used some die-chem and then scribed a 1-inch reference circle. Center my mill, then moving over 0.2 inches from the center, I center drill a 440 clearance hole, and countersink the 3 holes. Then I rough cut the disc out from the base stock, ensuring I stay outside of my reference circle, and turn my attention to making the lathe fixture. I'm going to be taking the fixture out of the lathe, doing some machining on the mill, and then returning it to the lathe. So it's important to note the orientation of the chuck so I maintain concentricity. I turn down the fixture just a little bit so I can find the lathe center on the mill. This I do with my edge finder. Then I center drill and tap the 3 matching holes for the center contact. I return the chuck to the lathe with our workpiece attached, and now can turn it down to our 3/4 inch outside diameter, centered on our 3 holes. I return the chuck to the mill, square up on the 2 screws, again use the edge finder to find the center of our workpiece, and proceed to then machine off the flat. If I had secured the workpiece to the fixture the first time I had it in the mill and machined the flat then, before we turned down the outside diameter, I would have saved myself a second setup here in the mill. Looking at the print, it appears that I could hit the screws on my last pass cutting the flat on the center contact, so I remove 1 screw at a time on the last pass of the flat end mill. A little bit of cleanup with Scotch-Brite, and we've finished our center contact for our distributor. The outer contact we'll make from this piece of brass stock here. We'll first turn 3 of the buttons and put in the countersink on the lathe. Then we'll make a fixture to allow us to cut these 2 radii, here and here. That'll be the challenging part. We load up our brass stock in the lathe and turn down the outside to the largest dimension of the button, which is 3/8. Then we center drill and drill for a clearance hole for the 440 flathead screw, and finally countersink for that same flathead screw. To reduce waste, I use a cutoff tool to bring the diameter of the stem down to 0.1875. A little cleanup with the file, and then we part our contact off. All right. Let's just make 2 more of those, and we can begin working on our fixture. Our fixture starts off as a 3/4 inch by 1 1/4 inch square block of aluminum squared up in the 4-jaw chuck in the lathe. I drill a 1/2 inch hole and then bore it out to center the hole on the axis of the lathe. Then, just as we did before, we take the whole chuck out of the lathe and mount it in the mill, squaring it up, and then use our edge finder to locate the center of the hole, centering the DRO at this point. The contacts are located a 1/2 inch off the center of our distributor. So we center drill, and tap 440 holes here with a .1857 countersink so the contact sits down in the pocket. Then we do the same thing for 2 other contacts, using a little bit of geometry to figure out where the one off center goes. And then it's back to the lathe. We bore the center hole out to 0.75 inches to match the diameter of our center contact, and then test fit the rotor to see how we did. Then we turn the outside of the contacts, test fit this into the distributor body, do a little bit of cleanup, and we're done. Congratulations! That completes the distributor for our Wallaby 30cc engine. Until next time, I'm Greg. Thanks for visiting me in my machine shop. Take care.